APIs are like doors into your system. If you leave them unprotected, then attackers and anyone can walk right in and do whatever they want with your user data and overall the system. That's why in today's video we'll look at 7 proven techniques which will help you to protect your APIs from unwanted attacks. The first one we have in the list is rate limiting, which controls how many requests a client can make in a given time. For example, you can set a limit for user A to make, let's say, 100 requests per some period of time to your API. And if they cross that limit and let's say make 101 requests, then you block the next request and allow some time to pass before they can send their next request. If you don't set this to your API, then attackers can overwhelm your system. They can send like thousands of requests per minute and then overwhelm your API, which will take your system down, or it can also brute force your data. And these rate limits can be set per endpoint. For instance, let's say you have some /comments endpoint, and here they can send a request to either create a comment or fetch comments. You can set that limit for endpoint level, so these comments endpoint will be set to some strict number of requests per minute. You can also set it per user or IP address. Let's say in A we have the IP address of first user, and then B for the second, C for this one, and your attacker has some IP address which corresponds to D. If you get the 101th request from the D IP address, then you will know that this user overused the API, so you will block it at the user IP level. And there is also overall rate limiting to protect from DDoS attacks. Since you can set the rate limit to work per user or per IP address, that means that this attacker alone cannot send that many requests. You will block it with your rate limiting in the API. But what they can do is they can spin up some bots, and each bot will have their own limit, right? Let's say you've set it to 100 per IP address. So each of these bots has 100, and overall they have more than you would allow or your system could handle. That's why you have also overall rate limitings, which can be some bigger number. So whenever all the traffic coming into your server reaches or passes this number, then you will temporarily block all requests until you find out the root cause. And of course, these numbers are just examples. So in reality, it's much more than 1,000, but that's just an example. The second one on the list is CORS, which stands for Cross-Origin Resource Sharing. This controls which domain can call your API from a browser, and without proper CORS, malicious websites could trick users' browsers into making requests on their behalf. For instance, if your API is only meant to serve your front-end app, which is at app.yourdomain.com, then only requests from this source should be allowed. If anyone else sends you a request like app.anotherdomain.com, then you should block this request and not allow them to use your API for authenticating or using any of its data. If you'd like to learn these and other system design concepts in much more detail so that you can land senior developer roles with higher paying salaries, then you can check out the first link in the description, which will be a link to my mentorship program. However, this is not for beginners, so if you're an absolute beginner or you're a computer science graduate and you're just learning the fundamentals, then this is not for you. So you should at least have 1 or more years of experience as a developer, and I'll help you to get to senior roles and higher paying salaries in the program with the one-on-one mentorship. So fill out your details there to see if you qualify, and if you do, you'll meet in a call either with myself or someone from my team, and we'll help you to get to that senior developer role. The third one is also a common one, which is SQL and NoSQL injections. Injection attacks can happen when the user input is directly included in the database query. For instance, attacker can modify it and send some queries to read or delete your data. Here, for example, this part bypasses the checks entirely, and then attacker can use this query to start reading data from your database or modify anything, or they can also delete all the data, all the user data, and any other tables that you have in this database. So to fix this, we always use parameterized queries or ORM safeguards. The next technique to use is firewalls. A firewall acts as a gatekeeper, filtering the malicious traffic from the other normal traffic. So typically you have it between your API and the incoming traffic. For example, if you use the AWS's Web Application Firewall, these can block requests with unknown attack patterns, such as suspicious SQL keywords or strange HTTP methods, which means it will block any suspicious requests from attackers, but it will allow others to bypass the request and reach to your API. Some APIs are also private and should only be accessed from specific networks. That's why we have also VPNs, which stand for Virtual Private Networks. The APIs that are within the VPN network can only be accessed by someone who is also within that same network, which means that some APIs are public facing, meaning these APIs will allow any requests from the internet from your users. But these, for example, can be within the VPN network, which means if a user from web tries to reach your API, then this request will be blocked because the user is not within the same network. But on the other hand, if you have another user here, which is within the VPN network, they can make a request to these APIs, and in this case, they will bypass the checks and their request will reach to your APIs. This is useful where you have internal tools. Let's say you have internal admin dashboard and the API for this admin panel will only be reachable by employees connected to the company VPN. Next, we have CSRF, which stands for Cross-Site Request Forgery. This tricks a logged-in user's browser into making unwanted requests to the API. Let's say you as a user are logged in into your bank system and your bank system uses cookies for authentication. If the bank system is not secure and they only use session cookies, another malicious site might use your cookie and submit a hidden transferring money request through your cookie. So to prevent such attacks, companies also use CSRF tokens in combination with session cookie. So the banking system will check if the session cookie is present, but it will also check if the CSRF token matches with the one that they have. And if it doesn't, then it will block this request from the other unknown source, while it will allow request from your behalf. And the last one we have is XSS, or it's also called cross-site scripting. This lets attackers to inject scripts into web pages served to other users. For example, if you have a comment section and this comment gets submitted to your API, next your API will also store it in a database. You can get normal requests like nice picture or something like that, and this will get to your API. Your API will store it in the database, so everything is fine there. But what if an attacker places a script in this comments section, and within this script they can try to do many different things. For example, they can try to fetch the cookie for another user, or they can try to inject something into your database. And if you allow this, then it will reach to your server and the information will be written into the database. Later, when the other users load this comments section on their screen, they will get also the injected comment directly into their web page, and the browser will execute this malicious JavaScript code into the other user's browser. These are the most common ways to attack an API and how you should protect it. If you'd like to learn all of these hands-on with a real system and with my guidance, then check out the first link in the description to apply for the mentorship.